called Eian. My metric number is CB15173. My contribution for coding is 40%. I figured out how to convert the plate number in the image into a text to prompt to user. And for the report part, my contribution is 30%. I do the discussion and the conclusion in the reports. That's all from me. Thank you.
Good afternoon, everyone. My name is Dr. Cheng. My metric number is CB15177. So for the coding part, I contribute 30% of the part. So I figure out how the image upload to the server. I even go buy a new server for the image upload and then retrieve from the server. So for the report, I done 35% of the report, include the methodology and literary review. For the methodology, it has 4 steps, which is pre-processing, plate extraction, character segmentation, and character recognition. So that's all from me. Thank you.
Hello, my name is Jing CB15170. So for the coding part, I'm in charge of 30% of it. So I'm mostly in charge of surface view and solve some critical bug and error. So for the report part, I got 35%. So I'm mostly in charge of the introduction, objectives, problem statement, scope, and some of the literature review and compile the report. That's all. Thank you.
Hi all, it's me again, Eian. So I would like to talk about code in the MATLAB. So our function name is plate detection, and this is to clear the text in command window, and this is to close all the files opened by MATLAB, and this one is to clear all in the workspace. So the next part of code is used to read the image from the server. The image from the server is captured by using the Android phone and will be saved into the server. MATLAB will read the URL of the image and save into ori image. So next, image will be resized to get the best result for the character recognition. So we're using the image resize, the built-in function, to the height of 400. So will be saved as a resized image. After resized image, we convert the RGB image into the grayscale image. But if the image is already a grayscale image, so we won't convert it. So this is to test the image is either RGB or a grayscale. As a RGB image, the size will be equal to 3, and for the grayscale image will be equal to 1. So image will be converted into grayscale. So the position of region of the interest, ROI, is already set by us, because the region of interest in the position of the region of interest is being tested with the many image that we use, and we selected the best rectangle region for the region of interest of a car plate number. We're using the IMREC to get the position of the number plate. So the position is 179, 265, 172, and 50. So next we will use a OCR function. OCR function is a function that read a text from the image. So in the OCR function, the image will be pre-processing into a binary image by using binarize, and after that we're going to the top hat filtering and top hat to compute the morphology opening of the image, and then subtract the result from the original image. I'm top hat using strel, strel. Strel is a flat morphology structuring element. A flag structuring element is a binary value neighborhood, either 2D or multidimensional, in which the true pixels are indexed in the morphology computation and the false pixels are not. So the next step in the OCR function is erode. This will erode the image to remove the thin lines in the image, and after that we'll go to reconstruct. To reconstruct the image marker under the image mask. Marker and mask must be the same size, and the marker element must be less than or equal to the corresponding elements of mask. So we will get the OCR result from the OCR function. So this part is used to print text to the user in the MATLAB mobile, because our apps is using the MATLAB mobile. So fprintf is used to print the text of OCR result.text, means the text that recognized by the OCR function. So next, this part of code is used to add generated car number plate into the resized image. Means like we will add the recognized text into the image beside the number plates. And the last part is to use to prompt a message board to user in the PC. The MATLAB PC means the simulation PC about the car number plate. So user will be told that your car number plate is like example DCR 7777. So let us run this plate in the simulation PC for more clear instruction. So this is a prompt message to the user so that our car number plate is BML4391, and this is a text with the original image, the original resized image, and this one is the grayscale image, and the last one, this is the original image that we use Note 4 to snap the image. Thank you, that's all from me for the MATLAB code. Bye.
Hi everyone, my name is Dr. Cheng. Today I will talk about the flag detection in Android Studio. So first of all, we have to go through the Android manifest to add some user permission. So which is the camera permission and internet permission and the write and read external storage. This for the writing and reading the file. So and then we also have to go through the dependency, build graded dependency, to add some dependency. This one in the Wally is the important one, which allow our Android Studio to communicate with the server. So and then we have to go through the Java class. So first of all, we make the directory which is camtest, so which the photo will be stored into this directory. So we can we make the directory here, and then we output the file to the directory. So after that, the image we get, we set it into bitmap. So we get the path and then we set it into bitmap. This is the function bitmap factory. And lastly, we convert the bitmap image to string. So this is the function image to string, which convert the bitmap to string. And then lastly, we upload the string image to the server. So we can see here, so we post the image with string to the server. We're using the PHP to run it. So as we can see here, this is our PHP code, which we get the image post from the Android Studio class. And then this is the image path we set, and then this is our domain name. So if there is a image stored inside, we will unlink the image, so which means we will replace the image. So else, if there is no image, we will add the image. So we will see here, this is the folder Eian. and then 123.jpg. So the image will be uploaded to here. When we capture the image, and then the image will be uploaded to this folder, of course with the internet running lah. So I think that's all from me. Thank you everyone.
Hello, my name is Jing and I want to talk about some coding in Android Studio. So first is the import, and second is declaration. This part is declaration, and this part is very important. This is draw. So we draw a green box on the interface of our phone, and then people need to put the car plate inside the green box, align with it, so that our system can read the car plate properly. And this one is called the surface view. So we set the flash mode off and the focus mode auto. And this one is refresh camera. And lastly, the most important is this one, start MATLAB. So it will start the MATLAB after we capture a picture. So we'll transfer to our MATLAB in our phone. Thank you, that's all.
Hi.
Hi.
Today I would like to invite my friend Theo Baymax to help us to test this system. Okay, let's start. Bye, thank you.
Bye.
Hello guys, so now I want to test on the Universiti bus. And now okay.
Okay, now I would like to capture this car, kendaraan fakulti. So I will test on this car. So let's begin. Okay.
Ba 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 banana. Ba 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 banana. Oh, ba 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 banana. Ba 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 banana. Ba ba banana. Tokari no potato rika ni maroma ni kanotika. Ba 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 banana. Yo plano fu, la pano no tu. Ma banana la kamo pitara mo banana. Ba 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 banana. Potato. Tokari no potato rika ni maroma ni kanotika. Ba 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 banana.